Hey guys, welcome to your Friday e-learning. We got a quick set of notes here. I'm going to work through those with you right now. And then you got a quick homework following that up. And that'll be your Friday e-learning for today, Friday, May 7th. All right, so let's get to these notes. We did the lab earlier this week. We are now in Unit 14, our final unit for the semester, Thermochemistry. And 14.1, where we're setting off here, is phase change diagrams. Now, as we get into these, it's gonna be a graph. They are a graph, but they're different than the one we did in lab. So what we did in lab is called a heat curve, and we were looking at the temperature changes of water as it went from ice, and then we heated up the water, and then it went to vapor. That's completely different. We're going to talk about that more next week. This is something a bit different. So, a phase change diagram. The phase change diagrams we're looking at today are a chart that measure pressure versus temperature, different pressures, different temperatures, and then what we're charting So what we're charting at these various pressure and temperature points are the phases that a substance has. So phases, hopefully you guys are aware of solid, liquid, and gas. Those are the three phases. So depending on the temperature or the pressure, what state of matter, what phase of matter is the substance you're looking at. Often we're looking at, water, not watt. Often we're looking at water. That's our substance. In fact, that's the one I'm going to diagram for you now. But it doesn't have to be water. We can look at any substance there is. They all have the three phases. They'll look a little bit different. I think you guys can take a look at phase change for carbon dioxide in your homework tonight. So it doesn't have to be water, but the one we'll take a look at here will be water, and that's probably the most common one. So again, we have an X and a Y plot. We plot pressure, usually measured in atmospheres, versus temperature, which is measured in Celsius. Back to Celsius for this unit. I know we just did thermochemistry, and we're always converting to Kelvin, but we can go back to Celsius for much of this unit. And most phase change diagrams have a general trend line like this, and then another one. And for waters, it kind of bends backwards like that, which is somewhat unique for water. Most of these lines go that way. And what these lines are these lines are separating our states of matter. So over here, this is the solid area. This whole region right here is solid. Up here, this is our liquid region. And down here, this is our vapor area. This is our vapor region. So solid, liquid, and gas, vapor. Usually have a cross, so you can cross that line right there. And anytime you cross from the solid state to the liquid state, you cross that line, that would be melting. Going in this direction, freezing. So taking a liquid and making it solid. can do the same thing when you go from liquid to vapor. And if you're going from the liquid to the vapor, that's called vaporization. And there's two main forms of vaporization: boiling, that's when the heat comes from above, and evaporation, and that's when the heat comes from above. So the boiling, the heat comes from below. Excuse me, I think I said that wrong before. And evaporation, heat comes from above, like the sun. And going the other direction, so if you have a gas and you turn it back into a liquid, when you cross the line in that direction, it's called condensing or condensation. Now, you may or may not be aware, though, that you can also go straight from solid to vapor and vice versa, straight from vapor to solid. You just skip right over the liquid part altogether. So when you go from vapor to solid, that process is called a deposition. It deposits. And the other direction, going from a solid to a vapor, is called sublimation. So that is a, oops, dropped my pencil. That is a sublime to sublime. So sublimation, that's probably a new one. That is when you go from solid to liquid. Solid to gas. And deposition is when you go from deposit, is when you go from gas back to solid. So it is possible. A couple more things to add. This point right here, we call the triple point. We'll talk more about that in just a second, but this point right here is called the triple point. Perhaps you can guess why. It's right there in the middle of all three phases. And then oftentimes, I'm actually going to race just a little bit here so that this line comes back. Usually, the line separating liquid and vapor has an endpoint. It stops. This line here continues to go, at least for a while, but this line often stops, and this is what we call the critical point. Again, we'll take a quick note on that in just a minute. We have the triple point here and the critical point there. One more thing I'm going to add. Nope, not right there. I'm going to go up a little bit higher than that. We call this 1 atmosphere. Oftentimes you'll ask or be asked, where is the normal freezing point or the normal melting point? Well, that would be wherever you cross from a liquid to a solid, that would be freezing, or solid to liquid, that'd be melting. Wherever you cross this line at 1 atmosphere. So whatever that temperature is, that would be your normal melting point. Same thing then if you continue this 1 atmosphere to where you hit the line going from liquid to gas, this would be your normal vapor point. So normal melting point, normal vapor point. So that normal implies you're working at a 1.00 atmosphere, a normal amount of atmospheric pressure. For water, this is at 100 degrees Celsius. This one's at 0 degrees Celsius. Those are the normal melting points and boiling points for water. The whole Celsius scale is based on water. So it freezes at 0 degrees and boils at 100 degrees. The critical point for water, 374 degrees. And I'm not going to have equal access here, but tough to see. It would be a lot of nothing if we did. 217.5 atmospheres. That is the critical point for water. All right, so this is a phase change diagram. And again, it's showing us, here's the solid area, the liquid area, the vapor area at different pressures and temperatures. Where do you cross those lines? Where do you condense? Where do you freeze? Where do you do these different phase changes? And that's what this diagram shows to us. As I mentioned, I want to give you a couple of notes here. The critical point. And we labeled ours right up here. So the critical point You'll find this on most phase changes. Most substances have a critical point. It is a pressure and temperature So above this pressure and above this temperature, so you get above 217.5 atmospheres or above 374 degrees Celsius, you get above either of those, and it's no longer possible to distinguish between the vapor and the gas stage. So that line there ends, and anything up in this area, supercritical fluid. It's not really considered liquid. It's not really considered gas. So that's kind of a cool point on the graph. The next one, the triple point right there, and you might have already guessed what this one is. So the triple point is the pressure and temperature combination at which all three phases of matter can all simultaneously coexist. So we did that lab the other day where we kind of had ice and water at the same exact time. Well, at the triple point, you can have all three, ice, water, and gas, vapor, all at the same time. If you get to a low enough pressure and low enough temperature, you'd reach the triple point of water. So pretty cool area. One final thing, you already kind of mentioned it, but anytime you're asked about normal, normal means at 1 atmosphere. At 1 atmosphere. So a lot of times, again, they'll ask, what is the freezing point for a certain substance? What is the normal freezing point? Well, you find 1 atmosphere. That's normal. We're under 1 atmosphere pressure. 1 atmosphere pressure, you go over, you find where it crosses the freezing line and you follow it down and you give it a temperature. And that's how you answer, what is the normal freezing point? What is the normal boiling point? All right, so that is your notes for today. You got a quick homework, just reading these types of graphs so you guys can get to it, and that's your Friday e-learning. Have a great rest of your weekend, and I'll see you guys next week. So long.